Okay, so there are two tests that we can use to identify if a primary or secondary alcohol or possibly an aldehyde is present, because the reagents will react with the primary or secondary alcohol or the aldehyde and produce a color change. The first one is the acidified permanganate test. So what we do is we take a sample, and it could be a sample of a primary alcohol, and to that sample we add some acidified permanganate. That is a permanganate solution that has acid added to it. We add it to the solution. The permanganate is purple for a start, and we place it in a water bath. Now sometimes we don't need to place it in a water bath, it will start reacting straight away, but if we have it in a water bath for 5 minutes, we'll notice that the solution will go colorless. Now this change from purple to colorless is the indication that this is a positive, that an oxidation reduction has happened, and it is a positive test, remember, for primary or secondary alcohols or aldehydes. So what happens, remember, with a primary alcohol here is the alcohol group is oxidized to form a carboxylic acid, and remember, it will go through an aldehyde intermediate on the way there. A secondary alcohol would be converted to a ketone. Okay, so let's just summarize this. If I had a primary alcohol, I add the permanganate to it, it's going to turn into an aldehyde, and the color will change from purple to colorless. If I have a secondary alcohol, it will turn into a ketone, the color will change from purple to colorless. If I have a tertiary alcohol, the tertiary alcohol cannot be oxidized by the permanganate, and it will stay purple. If I have an aldehyde, it will react with the acidified permanganate, and it will go to a carboxylic acid, and you'll observe it goes from purple to colorless. The ketone will also not react with acidified permanganate, and it will stay purple. So if we have unknown solutions, and one contains a primary alcohol and one contains a ketone, we can add acidified permanganate to work out which one is the primary alcohol. We can use acidified dichromate in exactly the same way as we use acidified permanganate. Now the only difference is the change in the color. So we take the same sample, an alcohol, primary alcohol, let's say, and we add to it acidified dichromate. Now acidified dichromate is an orange color, and we add it to the solution and mix, it's orange. We take this sample, we place it into a water bath, and over time it will become a green-blue solution. Now what's happening here is the orange dichromate ions are turning into green chromium ions. So this of course can be used to oxidize primary alcohols through aldehydes to carboxylic acid groups. It will also oxidize secondary alcohols to aldehydes. Now remember, it also will oxidize not to aldehydes, to ketones. It will oxidize secondary alcohols to ketones. It will also oxidize primary aldehydes to carboxylic acids. So the positive test for the acidified dichromate, and remember we're testing for, is there a primary or secondary alcohol or possibly an aldehyde present, is that it will go from orange to green. So if we took a primary alcohol, we added orange acidified dichromate, it would turn into an aldehyde. If we added it to a secondary, it would turn into a ketone. If we add it to a tertiary, there would be no reaction. If we add it to an aldehyde, it would turn into carboxylic acid, and if we added it to a ketone, it would not react. Exactly the same reactions as acidified permanganate. And we get the same color changes. Remember, for the primary and secondary, it will change from orange to green. For the tertiary, because it doesn't react, it stays orange. For the aldehyde, it would go from orange to green, and for the ketone, it would also stay orange. And that is the acidified dichromate test. Okay, so these two tests I'm about to introduce are used specifically to identify if an aldehyde is present. Now they are oxidizing agents. Phenyl solution here is an oxidizing agent. It is a very weak oxidizing agent. It will not oxidize a primary alcohol to an aldehyde, and it will not oxidize a secondary alcohol to a ketone. However, it will oxidize an aldehyde to a carboxylic acid. So that second part of the primary alcohol reaction, where a primary alcohol goes to an aldehyde and then to a carboxylic acid, it's not strong enough to make the first part of the reaction happen, but it's strong enough to turn an aldehyde into a carboxylic acid. So this is like a definitive test for an aldehyde. So the first test we can use is called phenyl solution. Now phenyl solution is essentially Benedict's solution. So what you would call Benedict's solution if you're a biologist is phenyl solution if you're a chemist. So we know that that is a blue solution, and if we add that to our sample of aldehyde, the solution is going to look blue. And if you remember back to your early high school chemistry or science, you take phenyl solution and you put it into either a warm Bunsen burner or a water bath for about 5 minutes, and it's going to change color. It's going to turn from blue to orange. Now what's essentially happened here is the blue copper ions that are in the phenyl solution have become an orange copper oxide or cupric oxide, okay? And this, the blue copper ions have oxidized this aldehyde functional group here into a carboxylic acid functional group, and the colors change from blue to orange. We know this is oxidation because the actual copper ions have the oxidation number of copper has changed from +2 and copper 2 plus ions to +1 in copper 2 oxide. So copper has been reduced as the aldehyde has been oxidized. So the other test, and this is this is kind of a fun test to carry out, is called using Tollens reagent. And it's called the silver mirror test. So if you need to make Tollens reagent is just silver nitrate. We add a little bit of sodium hydroxide to make a precipitate of what is that? Silver hydroxide, and then we add some ammonia, some concentrated ammonia to complex the silver ion to make it a silver ammonia ion. And we get this clear solution, and this is called Tollens reagent. So we go through a couple of steps and we have Tollens reagent. Now in class you might carry this out. The Tollens reagent may be given to you, or you might have to make it first. So we have some Tollens reagent, and what we do is we add it to the sample, or we add a wee bit of the sample to the Tollens reagent, and we place the Tollens reagent in a water bath. If the sample has an aldehyde in it, then what you will notice after you've heated it for about 10 minutes, it will go kind of a dark grey color for a start, and then you'll get this silvery sheen on the inside of the glass test tube. It is silver metal being deposited there, and you will notice a silver mirror, hence why this is called the silver mirror test. Now what's essentially happening here is the silver ions are being reduced to silver metal. So the silver ions in this complex have been reduced to silver metal, and at the same time the aldehyde is being oxidized to the carboxylic acid. So both of these, Phenyl reagent or Tollens reagent, will only oxidize an aldehyde. So are a definitive test for an aldehyde. You need to remember their color change. Phenyl solution will go from blue to orange if an aldehyde is present, and the silver mirror test, Tollens reagent, will produce a silver mirror if an aldehyde is present. Okay, let's look at a couple of example questions we might see. So explain how phenyl solution can be used to distinguish between pentanal and pentan 3-one. Your answer should include observations, the type of reaction occurring, and the structural formula of any organic product or products. Now, we need to remember the color change for a positive reaction for for phenylene solution. I call it Benedict's, similar, different name, same solution. So what we would do here is we remember that phenylene solution is blue and it will go orange if it has reacted, and it will only react with an aldehyde. And what you'll notice here is the two compounds given. We have pentanal, which is an aldehyde, and 3-one, which is a ketone. Now ketones cannot be further oxidized, and an aldehyde can be oxidized by phenylene solution. So we're just going to describe what we would observe here. So if I add 2 mils of each sample and 1 mil of phenylene solution and heat in a water bath, and remember I do have to heat this, the sample that changes from blue to orange is the aldehyde pentanal. This is an oxidation reaction because it produces pentanoic acid. So they wanted us to say what type of reaction, so I've specifically said oxidation here, and I've stated the observation. I haven't drawn the product yet, so let's do that. The product here is pentanoic acid, and then finally we want to just say that the pent-3-one does not react with the Benedict's solution. Okay, let's look at another. Right, describe a series of tests you could carry out, include expected observations, and include appropriate equations to distinguish between unlabeled samples of butanal, but1-ol, and 2-methylpropan-2-ol. Okay, so butanal is an aldehyde, but1-ol is a primary alcohol, and 2-methylpropan-2-ol is a tertiary alcohol. So we have an aldehyde, a primary alcohol, and a tertiary alcohol. So to 2 mils of each of the samples, add some phenylene solution and heat in a water bath. Now the only one that's going to react with this is going to be the aldehyde, and that's butanal. The sample that changes color from blue to orange is the aldehyde. The second thing we could do is we take the 2 remaining solutions, because we've identified one of them and removed it. So 2 mils of the other 2 samples, we add acidified dichromate. Now remember, acidified dichromate will react with primary and secondary alcohols, but not tertiary. So the sample that changes color from orange to green is the primary alcohol butan-1-ol. Therefore, the last sample is methylpropan-2-ol. Now remember that we needed to, for this first explanation here, have written the equation for the reaction, because it wants the appropriate equations and the appropriate equation for the production of, well, I guess both of them produce butanoic acid. There you go.
Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.